Oh, hello and welcome to this video showing you how to install Linstor and Cloudstack on a free node virtual machine setup. My name is René Painter. I'm a developer at Limbit and mostly responsible for Linstor and plugin development there. So we have three nodes, one called Cloudstack 160, 161 and 162. I already set up the network there, so it's just a simple setup of one network interface and one cloud bridge needed for Cloudstack. I think what's still missing is add all the hosts to the DNS resolving or at etc hosts, so each node knows the IP and name of each other. So let's check. Seems to work. Yeah, and before I forget, we will also make sure that SSH, it is possible to log in from SSH with root and a password, the root password. This is needed for the Cloudstack installation afterwards, so the hosts can be added to Cloudstack. Just check if this correctly worked. Yes, okay, and then restart. This is HDemon. So now the basic setup is finished. Yeah, we will start with installing also the ZFS utils, because Linstor will use an ZFS pool for the setup. So we get ZFS running. I have already added a disk to all those virtual machines with capacity of 60 gigabytes. And now we'll simply create a C pool on each machine. Check that shortly. Seems good. And now we will add our Limbit PPA repository to these Ubuntu machines. These are, by the way, Ubuntu Focal, so the latest LTS release. And for that, Limbit provides PPA for testing customers, but if you're a real Limbit customer, you should use our internal repositories, which you will get access as soon as you're a customer of Limbit products. So let's add this, update the package lists. And now all the Limbit software should be accessible. And with that, we will install for now on all machines DRBD, which will be used for all the data replication behind. And each node will use a Linstor satellite, which is kind of the same as the Cloudstack agent. So this is the software that actually does creating ZFS volumes or LVM or logical volumes for LVM and all system commands we need to provide storage. Apart from that, there's also the Linstor Controller, which is kind of the same as the Cloudstack management software. So this is the component that manages all the satellites, and the controller keeps connections to the Linstor satellites and also sends requests on what is to do to the Linstor satellites, and yeah, manages this, or is the controller for it. That's why it's the name. We will install that as soon as we have the satellite installed on all of them. For that, we will also restart the Multipath D daemon, Multipath daemon on Ubuntu, because DBD installs some block file or an exception for DBD devices, because Multipath D will otherwise sometimes get in conflict with opening the devices, and this can lead to some strange errors or when trying to down a DBD device, and we don't want that to happen. So we will restart the Multipath D daemon. And now we will just install on our controller node, which is Cloudstack 160, the Linstor Controller and Linstor Client. Linstor Client is command line client to execute commands. You need to set up set up the storage pool for Linstor, or if you would want to do a manual resource, for example, you could create a NFS resource for the secondary storage for Cloudstack with the Linstor client. And yeah, that's why you need it. So then we will enable and make sure Linstor Controller is started right now. And we'll also on all nodes enable and start or restart the Linstor satellite, just to be sure. And now we could start, or now we will start to add all those nodes to the Linstor controller. So right now we see there is no node added or node available, and we will change that now. So we'll start with our node the Linstor controller is running on. So we see a bunch of output here. So yeah, it's registered, it's authenticated. This is already from the connection step afterwards. And the Linstor satellite reports back what kind of storage providers and resource layers it supports and which one it doesn't support right now, because some commands or software behind is missing. So you see SPDK is not supported right now, or Exos, because we're missing for Exos the ls SCSI command, and for SPDK the RPC PI, which you need, there is separate software from the SPDK. And also for NVMe or OpenFlex, we need some kernel models which are currently not loaded or installed. But if you check the list now, we see we have one satellite node online, and the address. The address gets, because we did put an IP here, it just is resolved from the name, Cloudstack name here. But you could also just here specify the IP. Yeah, so we do that now for the other two nodes. Yeah, so all of them are added, and for Linstor to actually do anything, Linstor needs some backing storage or backend storage where data can be put on, or DBD can data put on. So we will have to create storage pools. I can show you right now what is there. So we see there is already some kind of storage pool, which is our default diskless storage pool. This is the default storage pool for diskless assignments, like DRBD diskless nodes, which will get this default storage pool by default. But yeah, as it's diskless, it cannot really save or store data. So we will create one. So this is the command. So storage pool create. We use ZFS here. The node name, the name of our storage pool for Linstor, which is our fallback name in Linstor is default store pool. So whenever you would need to specify a storage pool name, if you leave that out, it will default back to default store pool. So we use that functionality, so we don't have to type too much, which is in this case not really used, but just for the sake of having it. And yeah, and storage is the name of the ZFS pool on this node. So it's registered. Let's see again the command, and yeah, we have it here. It has total capacity of nearly 60 gigabytes and the free capacity of 57, which I guess is used by some ZFS metadata already. And we do the same for the other two nodes. And we are good. So now we will add a resource group. Resource group is a concept of having a main or a common entity to control all your resources from. So you can set on a resource group properties which are then copied or inherited from all dependent resources or resource definitions there. So you can then set properties on the resource group, and every resource that was spawned or created from this resource group will have the same properties until you override them on the specific resource. So it's just a way to manage resource. That's why it's called resource group. And for that, right now we have, as always in Linstor, we usually have default entities for all kind of objects. Here it's called also default resource group, but we will not use that because we will create our own full Cloudstack. And we'll do this with this command. So resource group create, our name of the resource group is Cloudstack. It has a place count of 2, which means there will be 2 replicas of data. So every time we have create a resource from this resource group, we'll have 2 copies of it on our cluster, or 2 physical copies. And we also specify the storage pool here to have the remaining disk size seen in the Cloudstack plugin. So it's created, and you also need to provide how much volumes you will have in a resource group, and it's usually just 1. There are some cases, but they're very rare where you want to have more. But for virtual machine setups like Cloudstack, you will just have 1, and so just creating 1 volume group without any additional data is good enough. So yeah, that's it basically from the side of Linstor. So Linstor is now ready to be used, so we can just for testing create us. In Linstor it's called spawn a resource from this resource group. So we have to specify resource group, and then the name of the new resource, I'll call it test resource, and the size of it. So say 1 gig. And it's ready, and we will have resources. So why resources? Because yeah, you get on a resource is an entity for each node. So we have the test resource on Cloudstack 160, and here we see from the state, this is the state from DBD. It's up to date, and this means we have a physical copy on Cloudstack 160 and 161, because here it's up to date. And we have a so-called tiebreaker on Cloudstack 162. So I can show you here that if we check DBD, here it's this class, and the other two peers are up to date. Tiebreaker is used for quorum. Quorum is to have a way to reduce the need of a fencing policy. So this is cluster speech of what would happen if one node would disconnect from the network. This one node would see itself as as the one that has the correct data and would maybe allow writing data to it, and the other two nodes, which know that these other node got disconnected from the cluster, will say, yeah, my data is correct, and this is done by voting, and 2 has the majority over 1, so the cluster, which is now just a 2-node cluster, will have the majority and know his data is good. And with this quorum set, this cluster, which just then would, because it's disconnected from the other side, will know, oh, I have only 1 vote, and this is less than 2 or less of the majority, so it would decide to not go or allow to write data to it because it doesn't have the majority in right now. So this is just a way to prevent split brain. But I don't want to talk more into that because this can get a very complicated topic. Yeah, so the test was good or succeeded, and now we'll just delete this resource again. And let's see, yeah, we are clear now. And we will continue with installing Cloudstack. So for now, we'll just use the 160 node, and we have to install their MySQL. MySQL is used for the Cloudstack database. Should finish in a second. All right, then we will create a database config for Cloudstack. I think are just a few performance optimizations. And yeah, because I might forget it. We also have to install the kernel NFS kernel server. So now restart MySQL to get new configuration recognized. And now we can start installing the deb files of Cloudstack. So on the management machine node, I'll just install all of my downloaded. These are already for 17 nightlies because Linstor got two UI fixes there, and these will also included in the next patch upgrade from 4.16. But just to run into this little UI bugs, I will use the current nightly builds, and we will install the agents on the other two nodes, which are just virtual machine hosts. And yeah, the install will fail right now because I didn't install the dependency yet, and as I don't have those packages as repository, I have to resolve the dependencies on my own. But you can just say apt install fix broken, and then it will pull all the dependencies and let apt fix it for you. So after that, we will then set up the database for Cloudstack with the install script from Cloudstack. Then create NFS export for the secondary storage on the Cloudstack 160 node. And after that, we will install the system virtual machine for Cloudstack. Then we will, on all nodes, tweak a few settings for the libvirt so that the TCP connection is allowed and ready, because that's how Cloudstack talks to libvirt or KVM. And after that, then we will disable AppArmor on all machines or add exemptions for libvirt so that AppArmor don't get in our way for security reasons. So that's ready. So as I said, I will now set up the Cloudstack database. Yeah, most Cloudstack commands I got from one blog article from Rohit, who is a Cloudstack developer. You should be able to find that if you search for Ubuntu and Cloudstack KVM setup. It's on his cloud page. I can you see it here. This is the URL. You can pause the video here if you want to be sure to have the correct link. So there is a guide or blog how to install Cloudstack on Ubuntu machine with all the setup stuff, network stuff, and all other things. I extracted most of the important stuff into this video here, but if you want to reread that, you can check that link. So now we will create a directory for the secondary storage and put it into our exports for NFS and re-export it. Let's see if that worked. Yes, good. So now we will install the system template. Right now there is only the 4.16 available, so there is no 4.17 yet. So I hope. Oh, I'm on the wrong directory. So I guess the 4.16 will also work with the 4.17 version. And after that, we will on all nodes change the libvirt settings to allow TCP connections. Even it says it could take a long time, it usually doesn't on my system. Yeah, it's already finished. Perfect. So then let's edit the libvirt D configuration and search for listen TCP. Enable that. Go to TCP port. Set it. And the off TCP should be none. Well, it shouldn't probably used for a production setup because it's usually for more for testing or exploring things, and for a production setup you might have to invest more time on the security parts of the installation. And restart libvirt. And yeah, the commands I execute now are also all taken from this guide. They're basically just putting some libvirt scripts or helper scripts into the Obama disable chain, and yeah, reload that so libvirt doesn't get denied by AppArmor. So yeah, that were all the steps, and now we just have to restart Cloudstack management, and we can check the restart status. Yeah, not like this. It's currently upgrading the database. But once that is finished, we should be able to access the UI from Cloudstack. So, database upgrade finished. Looks good so far. I guess it's finished. So let's access the default is admin password. Log in. And we're now provided with the Cloudstack install setup wizard. So let's go through that. Most of the things here I already have filled out at least once, so I will just pick my fillings. Right now the Linstor plugin only supports KVM. My network domain for the virtual machines is Virtua. keep the defaults here. Default my network. So call it my cluster. And yeah, pick the first host. This is the thing I mentioned on the beginning, that you need to have root SSH password access, so Cloudstack can add your host. Then now here we are on the primary storage page, and here it gets interesting, at least for that video. So I'll call my primary storage Linstor. Scope is Gusta. We pick Linstor here. Server, I tend to use the IP here, just to make sure that I don't have any resolving problems. Just 160, and resource group is named Cloudstack. Then secondary storage, we have NFS seconds. Yeah. So that's that, and launch. And hoping that everything goes well. Can take a while, but it's good when it already takes a while, because if it not works, it usually fails fast with adding host. I had at one live presentation the problem that my virtual machines didn't have the right CPU type, and so within the virtual machines nested virtual machines were not enabled or working, and so Cloudstack always failed here. I couldn't really figure out why in the beginning, but I made sure that this time I have CPU type host pass through, so that it works. But anyway, if, for example, the setup would now fail and we couldn't proceed, we can still close the wizard, and everything done yet would have already committed, and you just have to make the remaining steps. But the setup succeeded, and we can enable the zone now. Very nice. And we can go to primary storage and see it's working. We have one host. We can already add the other hosts. And in the meanwhile, I can show in the background, because Cloudstack should already start to get its system virtual machines running, like the console proxy and the other one for the secondary storage. And this should already have created resources in in Linstor. And yeah, here we have one. So I guess this is the template from the system virtual system VM template, which is currently copied. Yeah, that's exactly what's happening. So you can see that. Yeah, not sure if it's still writing. Doesn't seem so, but at least currently 4 GB are allocated. Okay, second host was added, so let's add the last one. And as soon as the copying is finished, Cloudstack will start to spawn or create the 2 virtual machines from away from that image. And so in the end, or in the basic setup after Cloudstack is enabled, this zone will be 4 resources or 4 independent resources. I mean, right now it's already 3, but what I more mean is resource definitions, which is some kind of, oh, so here we already have the next one. So this here will be, I guess, the console proxy. We can view as soon as the adding host is finished. So this resource is now copied from here to here. And as soon as that's finished, Cloudstack can start those virtual machines. Not this virtual machine. You can also check the backing disk, so ZFS, because all what Linstor does is, managing all the steps behind, so creating a C volume and put the DPD layer over it and provide the final device path then for Cloudstack, so Cloudstack knows where it can write to. Okay, so yeah, here we can check. So Cloudstack is currently starting 2 system virtual machines, one the console proxy and one the secondary storage. I'm not sure I can see the volume from here, which the virtual machine is using. I don't think this ID is the same, no, because this is hidden somewhere in the Cloudstack database. But yeah, so this copying was finished, so one virtual machine should really getting started right now. Guess the console proxy should be soon running. And the other one is getting ready. Yeah, this tends to be the slow because this is just done on my local storage and a bit of network storage. So, but my workstation is not super fast. It's not slow, but it's not a server or a production server you would have in your company. Yeah, let's check here. We have an aggregated storage of nearly 180 gigabytes. And system virtual machines are still starting. But they are all now, from Linstor side, they are done. And yeah, finally, the console proxy is running. Perfect. And so we'll soon Also, the secondary storage virtual machine is running now. Perfect. And what we could do now is just create a template here from an ISO. I will use an Alpine ISO here because they are small and fast. Perfect for testing and quick demonstration. There's just no OS type yet here for Alpine. Let's wait until this is downloaded here. All right, and with this we will be able to create some base Alpine installation, and from that create a template, and then this you can use to create virtual machine instance. Let's pick it here, Alpine KVM, perfect, small instance is good enough. 5 gig disk size. Let's call it Alpine base. Start and launch. So what's happening now again is Cloudstack will copy the template or the ISO into Linstor storage or storage provider, storage pool, sorry, which is currently done here. Or this might be even before that, the system router or virtual router. Yeah, okay. That has to be done before. So for networking of Cloudstack, so this should be again a 4 gig of copying. Okay, it's done. This should start soon. And after that, the ISO will be copied into the storage pool, and then it can be started into the machine. And I guess also, oh yeah, it's already running. So maybe this was just the, okay, this is the disk for our image. This 5 gigabyte user disk. We can Alpine install onto then. So let's see, yeah, mounted. And yeah, I don't want to install now Alpine, but just see we have, okay, not here, but block, which is not here in Alpine. Let's see the partitions, and here we have this SDA, which is our 5 gig provided disk from Linstor, which would be the same as this one here. This is reused, and as we see here, it's used on Cloudstack 162, and the Alpine here is running on Cloudstack. Where is this shown? Here on Cloudstack 162. What we should be able to is to live migrate this. Let's say to 161. Successful, so I can show you here. Yeah, it switched, so now it's in use on Cloudstack 161. And okay, the connection got disconnected, but we still have the same output from the VNC, so it didn't shut down or restart it. Yeah, and that basically completes my installation guide video of Linstor, or of Linstor and Cloudstack, and show you some basic operations. Apart from that, most operations, volume snapshots and so on should all work. What does not work is snapshot of virtual machines. Guess it will. You can put the volume here then. Maybe even work. No. Yeah. This is because KVM doesn't support snapshot of running VMs if the backing storage is raw, which in Linstor case is the case. So these volumes are raw images and no QCOR2 images. So Cloudstack wouldn't know where to put the memory stack, because you have to save that for live snapshots. But if you shut down the virtual machine, you can still do snapshots of the volumes. This will work. And this will create ZFS snapshots in the backend. Yeah, but that's it. And thank you for your time. And yeah, if you have questions, come to Limbit, and we have a Slack community channel there, so you can either ask there or hit us on Twitter, Facebook, and all other communication platforms, or old school email. So thank you.